So as a continuation of that, if we want to rotate the area that's bound between two curves, okay, well then the volume of revolution there is the volume of the top function squared minus, sorry, it's just the top function squared minus the bottom function squared, integral of that difference multiplied by pi. So if we, again, nice little quick sketch, 2x squared looks something like that probably. 4x fairly steep. So if we let 4x equal 2x squared, I get x is equal to x squared, so I get x squared minus x equals 0. So we get 0 and 1. So that's the point 1, 4. We've got the point 0, 0. So there's my volume, and we're going to rotate volume about the x-axis, okay? So we're going about the x-axis. So it's the volume, the x values between 0 and 1 pi, top function, which is the black function, which is the straight line, which is 4x squared, minus bottom function, blue line, 2x squared squared dx, dx, I write dy, dx. Yeah, so pi y squared dx, and y is the difference of the two functions. Okay, the squared, if you know what I mean. Pi outside of, let's simplify, 16x squared minus 4x to the 4. Might be inclined to take a 4 out the front. 4 pi between 0 and 1. 0 and 1. Took a 4 out. 4x squared minus x to the 4 dx. 4 pi outside of 4x to the 3 on 3 minus x to the 5 on 5 between 1 and 0, which is 4 pi times, so 4/3 minus 1/5, and 0 goes in there, we get 0. Side of 15, 20 minus 3, look about right, does sort of 4/17, 68 pi on 15 units cubed. Okay, so it's just continuation of the same philosophy and that we have in methods, in that, you know, the area between two curves is the top function minus the bottom function. So with our volume, it's the top function squared minus the bottom function squared. Yeah. So let's look at the next one. 1, 4. Yeah, so as a continuation, if we're going to rotate about the y-axis, we know that it's pi dy, and we'll call x1 squared minus x2 squared, if you like. So if we rearrange our two equations, there's my parabola there. X is equal to the square root of y on 2. My straight line graph there of x equals y on 4. Just refresh ourselves with the graph. We have our parabola up through there, and we've got our straight line through there. Yeah. Now, if we're going to rotate around this graph or flip to the y-axis, from the y-axis out, the top function when we're going about the y-axis is actually the red line in that case, which is the parabola. So in this case, I'm going to have pi outside of x squared, where x is the parabola first, y on 2 square root of y on 2 all squared, minus the straight line graph squared dy, which is pi outside of y on 2, because it's all square rooted, minus y squared on 16 dy. Oh, hang on. Something wasn't right. Y on 4, isn't it? Y on 4, which means I can take a 16th out. So I like to take the fraction out. We've got our limits of integration. So what were they? That was the 0.1400. So the y values are between 0 and 4. We have our 1/16 out the front, so that's going to give me a 4y minus y squared dy. So look, you don't have to take the fraction out, but I just like to take constants out. I'm less likely to make a mistake. 4y to the 2 on 2 is a 2y squared. Y to the 3 on 3, evaluated between 0 and 4, is pi on 16. What's y squared? 32 minus 4 cubed is 64 on 3 minus just zeros. So what's that? Equal to pi on 16 times 96 minus 34 is 32 on 3. I hope I've got that right. Which is equal to 2 pi on 3 units. I'll let you guys check that one on the CAS. Okay. Question C is actually a repeat, so that probably shouldn't be there. So we don't have to go through that because we just did that a minute or two ago. All right, so let's continue on with that exercise.